Hello guys, in this video I'm going to show you how to validate a tree if it is a binary search tree. So binary search tree is a tree that every node has at max 2 nodes, which is left node and right node. So for left child, the left child's value should be less than the parent's value, and the right child's value should be greater than the parent value. For example, 5 for the tree. For this tree, as you can see, consider this node 3 is less than 5 and it's a left node. The left child 5, so and 9 is the right child and it's greater than 5, so it is a binary search tree if we're considering only this subtree. But if we move down here, let's see, we consider another branch, a right branch. As you can see, 4 is less than 9 and 10 is greater than 9, so it is a binary search tree if you consider only the branch. But so you might think that this is a binary search tree and this is a binary search tree, this is a binary search tree too. It has no children, but so you might think that so it must be a binary search tree because all the subtrees are binary search tree, but it's not, because one important pieces that we're missing is that we only we are not considering the whole tree, but only the direct child of a tree. For example, we only consider 3 and 9, and for this tree we only consider 4 and 10, which is a direct child. But if we see the tree as a whole, then all the nodes on the right side should greater than the parent node, which is 5. But as you can see, 4 isn't greater than 5, so it is not a binary search tree for that reason. So to solve this problem, to solve trees kind of problem, we might think of recursion, which is trying to formulate the original problem and try to divide our whole the big problem into smaller problems. For this example, you might think of to validate the whole tree, we might try to validate the left subtree here and the right subtree here, and then if two subtrees are binary search trees, then the whole tree is a binary search tree. So you might think of writing some code like return the validate node left and validate node right. So if this is true and this is true, then the whole function return true, right? So Also, you might think of we need to check, right? We need to check also, like the node. We need to check the value of left child. For example, if we consider node 5, then we might want to check the value of right child, not dot right dot data greater than the current node, which is not data, and also node dot left dot data less than node dot data. You may want to check this also, but as we discussed earlier, this only check the direct child, the tree, the direct child, the current node. It doesn't consider the tree as a whole. So this might be a way to remember the parents data, right? For example, as we go down on the right side, we go here, right? Of course, at this level, we can know the value of its parent, but if we come down here for the node 4, we still have to remember 5, because all nodes on the right subtrees need to greater than 5, right? So one way you can think of is, for this kind of problem, is try to pass down the max and mean and max value, means and max. As you can see, for the root node, there's no mean and max, right? Because it's a root node, so it has no parents, so it doesn't have to greater than or lower than something. We don't restrict anything on the root node, right? So initially, if you don't pass anything, it should be no, right? We're not gonna check this because this is not enough anymore. So as we go down as we traverse down the tree, we can passing along with the mean and max. For example, here for the root node, there's no mean and max, so we just leave it no, right? But for 9, as we go from 5, so because we go to the right side of 5, right? So the mean value of all nodes that is rooted from 9 should have the minimum value of 5 and the max value. No, we don't have max value here, so it's no, right? So at this node, we also need to consider 2 branches, either overlap or override. So for 4, what's the mean value and max value? Let's see. the mean values because we come from the left side of 9, so we can determine the max value by 9, right? The max value is 9. All the nodes rooted from 4 should have max value of 9. And what's the left value? The left values is 5, right? This is for 4. We take the mean value from 9, which is in turn from 5, right? As we said earlier, all the nodes in the right hand side 5 is should greater than 5. So you can see as we traverse down the tree, we remember the means and max value. For 10, as you can see, 10 should we take you can see here is 9 and 5. So because it comes from 9 from the right side of 9, so the mean value is 9. We don't have a max value here, so the same for 3, right? The means value is no. We take no from 5 here, but because we come from the left side of 5, so the max value is the max value is 5. So that's basically how we remember that's basically how we set the lower bound and upper bounds for every node in the tree. So in order to validate our tree as a whole, right? So for the current node we're sitting at, the node, if we have a mean value, right? Because mean might be null, so we only want to check the mean value if it is not null, right? If we have mean, if means then null, then we want to check if mean is different than null and node is the current node, the data less than mean, then should return false. And same for max. If we have max, it means max is different than null, and node, the data current node is greater than max, return false. So when it comes here, it means the current node satisfies the constraints, right? And we want to go deeper the tree, go down further down the tree, and one missing thing here, we want to reassign the means max value as we go down the tree. So if we go to the left, we probably want to update the max value and the min value is the same as at the previous goal, right? So the mean values is the same, but the max value will be the current node, right? The current node data. And as you can see here, we're sitting right here. If we go down to the lab and we want to update the max value, this node to the value of the root node, right? Because this node can't be greater than 5, right? And same here, if we go to the right, we probably want to update the means, which is the current value of node the data, and max is a max. So one important missing pieces here is the case that what if we're sitting at the leaf node? Okay, if this node satisfy this one, no, if it doesn't, it satisfy the, if didn't return here, it means it are in correct conditions to go down, right? And so we try to go further down here, but we try to go further down to the left of the tree and the right of the tree, but the left and right of the tree is no. So we need to handle for the case. So for if the node, right? As you can see, node. If we're sitting a tree, the node on the left is no. We call validate again, passing known here. So if the node is no, return true. Return true for this case. Just validate. Let's run the test. Awesome. So it works. Thank you for watching. See you in the next video.